Welcome to Coding Adventures. Today we are continuing the discussion about classes and see other properties of classes and object-oriented programming. So let's get started. Alright, so I'm back here on my desktop, and before we actually start this lesson, let's look a little bit at the program that we developed in the previous lesson, shall we? And that was this one, with a player that was basically moving and jumping around on the screen, and we kind of modeled that kind of logic using the classes. So let's see the program again. Oh, it even shoots. It shoots big spiders and dinosaurs coming towards us. And if you remember from yesterday, we had a small issue, a small error in the program, and I want to fix that one before we move forward with the current lesson. So the problem was that if we have more than one player, so let's introduce the second player, like this, and basically we also call inside the loop the update and display logic for the second player, and perhaps let's move the first one a little bit to the left and the second one a little bit to the right. So yesterday we did this one, but the kind of first player had a little bit of strange behavior, and second player also was kind of in continuous state of running or jumping. And actually the error is pretty simple, was here. Instead of this, we typed player, which worked actually. We referred to the outer variable player, which was just one. But in the moment we introduced the second player, this kind of mistake just made the program totally unusable. So let's see now with two players. All right, so we have two characters on the screen. I can move them left and right with my cursor keys. I can jump, I can shoot. They are like a mirror image of each other. And this is expected because that's how we code it. Now, if we want to create this in a, or to transform this one in a multiplayer game, perhaps having a friend play with us at the same keyboard, perhaps we should make the second character accept different inputs. So we can move one perhaps with the arrow keys and the other one with the keys somewhere on the left on the keyboard. Anyway, I wanted to fix the program before we started this lesson. And as a recap also, I want to remind that this program was built basically with classes, simple classes that encapsulated all the logic, the movement of the character. We even did a little bit of a composition here, like we had the bullet and bullets, and the player had a collection, access to a collection of bullets, and so on. So let me eliminate the second one and save the program, and you should find it basically there on the chat. It's on the chat from yesterday. All right, so also, since we are at the chapter about recap, let me grab my notebook really quick here and put on paper what we built last time, basically. I'm gonna try to draw it in a different way. So, what we achieved in the code with that moving player, we had basically a player class, and I'm gonna just draw it like a big rectangle. I'm gonna name this player. And we had other two classes, basically. We had one bullets, and we even had one called bullet. So the entire program was organized or grouped in these three classes, and I want to represent them just like that because it's you know, it's a little bit easier to understand the logic what goes inside. All right, and now the player had certain behaviors, such as go left, which basically enabled us to call it and make the player move left, had go right, jump, right? And I think a few other behaviors that we declared them as being private. Had also shoot, by the way, which is not a, which was kind of not a private one, but even this one, in the end, we turned them into private ones. Being called from within the update and then display of the player. So perhaps these are the kind of the private ones, and I'm gonna put a minus in front of them. And what we basically exposed on the outside was that update method that we called from within the loop, and then we also exposed the display method, which basically was used to display the bullets. And other than this one, as an internal one, the player had also access to basically a full collection of bullets. So one of the inner member here inside the I'm drawing them in a little bit of a mixing public with private kind of things, but I think you still get the idea. Like for recap, we can also look at the code, which is here right in front of us, right? So also had this one, I tried to represent, had access to a bullets collection. So let's put this one on the paper as well. It was kind of private because we don't need the bullets, which was an array basically. And the reason was private is because the actual shoot was accessing bullets, and even shoot was private because you know, update was using that one. And basically player had an association or a rule of with this bullets class, right? So because we had inside here bullets, basically there is obviously an association between the player and bullets. And now, what are the main properties of the bullet class? Obviously, we had that method add that allowed us to add this kind of objects inside bullets. Obviously, bullets was a kind of a collection, so had a bullets property, internal one, and add was actually adding into this bullets collection each time we call it, and then had the obvious update and display. Thing that basically in some of our mini games we always try to create these two methods or two functions, two concepts, and display, right? And also bullets obviously had an association with the bullets, and obviously there is an 1 to n relation here. One player had multiple bullets, and so on and so forth. We don't represent that kind of information right now, but that's the idea. And then bullet, you know, had a regular update and display here. And then, you know, had other properties to verify if a bullet is outside, such as internal, like is outside. To know when a bullet goes outside of the screen. Remember, if this is the screen, a bullet, this is our character, and would shoot a bullet going this way. If a bullet goes outside, we want to obviously remove it from the bullets collection. All right, so these are the three classes that we defined last time here. And before we actually move to today's lesson, I just want to highlight the pattern that we use with update and display. Obviously, from the outside, we just invoking this one, update and display, and this one was basically invoked from our game loop function. So function loop. From outside here, we invoke player.update and then player.display. We didn't even use the other objects from the outside, and the reason is because inside this player update, these guys would also invoke the bullets update and bullets display, and the bullets collection obviously we're gonna, for each bullet we're gonna invoke the update and display. So then basically it's this starting from outside, go via update display here, and then travels via this way, goes into update display on this one, and then goes into an update display of this one, and of course goes also into the self update and display for the particular character that we have here. All right, so was a little bit of a long recap from last time, but now it's basically time to switch and define a few more classes and even introduce some new concepts when we are discussing with classes. All right, so maybe, you know, before we actually move and write code, let's spend a little bit time on paper here. And I want to basically kind of, let me grab back my pen here really quick. I want to this time to define inside the code a different type of hierarchy basically. Well, let's start from the natural world, right? So we know that in natural world we have animals. So let's I'm still representing like a class because at the end of the day we're gonna represent this with class, but I'm talking roughly speaking conceptually about animals, right? And obviously there are different type of animals. We have fish. Well, this don't take it too accurate. This is not a scientific kind of diagram of the natural world, but we have mammals here, to say like that. We have birds. Under mammals, let's say at one point we have a cat and a dog. Let's just get straight to the subject. We have a cat and we have a dog. And we are used to this kind of representation from real life, again from biology and natural sciences. It's pretty common. But today we're gonna see that this kind of representation is very easy to be modeled inside the coded classes. So basically we can have a class animal, like this. Animal, basically class. That will have some members, and the same for everything. Here we can have a class cat here, a class dog, and also from this diagram you see that these are not isolated kind of entities, or in our case isolated classes. They actually have a relationship between them, and in this particular case it's a relationship of inheritance, how we are calling. So basically dog in this particular case inherits from mammals, and mammals inherits from animals, right? So we're gonna see in our code how can we write this one, what can we do here to specify, okay, this dog inherits basically from mammals. Double M here. So there is a special syntax that will allow us to kind of inherit a behavior from an upper class. All right, so we're gonna see this kind of thing in the code. Probably this is pretty complex hierarchy. We're gonna probably design a much smaller one, perhaps just 2 levels. But the idea is the same here. So let's start with a blank new program here. And for the beginning, let's model an animal class. So we can model a class. We can define a class or declare a class just like this, right? And the question is, how can we basically define, let's make it simple, take baby steps, and instead of just defining that mammal and fish and birds and things like that, let's just focus on a cat and a dog. So obviously cats and dogs are animals, so they inherit from animals. So we have to see how we can define or specify this association. So to define a cat, we just define it like that. And to define a dog, we just define it like that. But right now the 3 classes are totally isolated. And the way we specify that kind of association is by saying here extend. So cat extend animal, right? And extends. And dog extends animal as well, right? So at this moment we have what is called a base class or a super class, and these 2 other classes inherit this class. And there is a really big benefit in doing this kind of extension or inheritance. Some programming languages call this inheritance. Actually, that's the right concept. Some have specific keywords. In JavaScript, the keyword to kind of inherit from another class is called extends. And in a sense, in a way makes sense, because this inheritance is like we are extending this base class with additional behavior. All right, so let's place perhaps some default behavior in the base class and then extend that behavior with other behaviors here. And since we're on a graphical program, why not go and actually represent this cat and a dog? So let's look here on the palette, and I think we have 2 sprites for cat and dog. So we plan obviously to use this one. So we plan to use a sprite basically. The problem is, when we are an animal, we don't know what sprite to place, right? So let's write a constructor here for animal. And constructor, as we discussed, is a special function inside the class that gets automatically called for us to produce an object in the moment we say new animal. So when we're going to say new animal, this constructor is called for us, right? And we want to have inside the animal a private property there called sprite perhaps. So we say this sprite, but at this moment we don't know what kind of animal is this one. So it's a cat, can be a dog, we don't know. So what we can do at this moment, we'll just say it's null. All right, and it's the first time we are encountering the null keyword here in JavaScript. Null is a special type of value that basically means lack of a value. It's like we want to say instead of in this sprite, we are just say this is null. It's like it's using combination with objects. So when an object is not instantiated, if we want just to say, okay, this particular variable points to something that is not there, we can say it's null. All right. So later on, we want to associate to put in sprite the actual sprite for animal and the actual sprite for dog, the actual sprite for cat and the actual ones for dog, right? So the way we're gonna put that, we're gonna define a constructor here and a constructor inside dog. And let's go on that palette and actually drag here the cat, because it does that autocomplete for us, a little bit of help, a little bit easier for us to write this syntax. So sprite is a special function in this environment that basically draws a sprite on the screen. It's special, but not rocket science. It just put a small image on the screen. All right, now we want to keep this one, and the sprite command actually returns an object, and we want to store this one inside the this.sprite member, and we can do that. We're gonna just say it like this. Now this one, it's an inner property inside the class, while this sprite is basically the sprite function or command. We could have not named this one T or any other letter. So don't mix it up with this one. This is totally different thing. This is a function that returns a sprite, but since this is a sprite, we're storing it in a variable properly named sprite. All right, now through the mechanism of extension, in the extended class here, so in the cat and dog, we are actually referring to this particular member that is defined in the upper class. So this dot sprite here, it's already defined here. In a sense, we are overriding that kind of behavior. But if we run the program right now, will not work as is. So let's try to run it to see the error. All right, we don't have an error. The reason is we didn't even instantiate any of these objects. So we can basically instantiate an object and basically try to see if we have an error, which we will have an error. So let's instantiate basically, let's say let animal is just a variable, new cat, like this. And if we run it, yep, basically it says that we need to call super before we actually accessing this. And this is a rule in JavaScript. When we are extending classes or inheriting from an upper class, before we actually use this, we have to call super, like this. It's again a special syntax, so we have to do this one here and here. What super is doing is actually invoking the constructor from the base class here, right? So when we are instantiating, let's look at the code. We are saying new cat. In that moment, this constructor is about to be executed, but inside the constructor, we have a super line here that will actually invoke the constructor from the base class. This will construct this property here, and now we can access this property here with this dot. And it's actually not only that property, it's constructing an object there and does all the plumbing for us. All right, so let's run this one. We have a cat. But let's change here and have a dog. And we have a dog, right? Which is nothing unexpected. But you may wonder, why mess up and have this animal class? We could have a dog and a cat just by defining two classes. Why make them inherit from a common ancestor here? Why this extra code to say it extends this one, put the super in place? Well, there is a very well reason. With inheritance, we can inherit behaviors written in the class, right? So what it means a behavior? Like we can inherit code. For instance, both cat and dog can move, right? We can send them at a certain position. So let's make them go to an X and Y. Normally, how we're gonna do? We're gonna implement here a move X and Y, or move to X and Y basically, or move to X and Y coordinate, right? And then we'll say this dot sprite equal X, this dot sprite equal Y. And the same for dog. And now we can say animal move to perhaps 100, 100, something like this. But we have a small problem. First of all, this dot sprite.x and this dot sprite.y. So sprite is the object return, and it has an x and y properties that allows us to position it, and it jumps at that coordinate, right? But we have a problem, and the problem is that we duplicated this code. Look at this method, it looks the same. And this is where the power of classes come into play. Since we have a hierarchy and both cat and dog move in the same way, what we can do is we can take this method from here, I just remove it, and I'm placing it in the animal class. And from the dog, I'm removing it altogether, right? So I define it just once in the super class. And now at runtime, when the program runs, both cat and dog, because they extend animal or inherit from animal, they actually have this method. And let's run the program now. And it's just running as expected. The cat goes at that position. Let's make it a little bit more animated, shall we? Perhaps we should have a function loop here. Really quickly, we really like animations here. And we can say animal move to mouse X and mouse Y. Mouse Y, like this. And we can see that we invoke that method each time we move the mouse. And this time we have a dog, and now we have a cat. All right, so this is the power of inheritance. We saw yesterday encapsulation. Of course, we can see again encapsulation here. We're encapsulating all this behavior. We see here also the power of inheritance. There are also other concepts kind of subtle in that we don't talk about, like polymorphism and other great OOP things from object-oriented programming, but maybe more about those in a future lesson. But for now, we just want to look again at the code, inspect that we have a base class here that has certain behaviors, has a move to, and then these classes, they don't have a move to, but they inherit that one. Also, very important, the base class doesn't actually contain any sprite itself. While the sprite is added into the other more specific classes, into the specialization of this class. In some sense, this one is called an abstract class, right? It does just mostly abstract things. Well, not everything here, but there's the idea, and these are actually classes that we can use in the code. There is no sense to call here new animal. Again, this is an abstract one, and in some languages actually you can mark a class as being abstract. In JavaScript you cannot. But if we're gonna just say new animal and we'll try to run it, we'll probably produce an error. And the reason is we're gonna call move2 method, and move2 will say this.sprite, which is null. Null, it's this kind of value that specifies nothing there, and that null will not have an X and an Y, right? Cannot set properties of null setting X. You cannot set .x to null. So this animal, again, it's abstract. You are not supposed to instantiate it in your code. You are supposed to instantiate only specific classes, like in this particular case, dog and animal, a dog and cat, but still is pretty useful because it encapsulates all this internal logic. Okay, I'm gonna share this program with you on the chat this time. And just a second, cat and dog, it's on the chat. And for people new to the stream, you can click on the link and open it on your side and run it and modify it and so on and so forth. All right, so let's do more examples in the same way to better get the grasp on classes and inheritance and so on. And one of the examples that I want to do, and we did it also last time, I think, was this one. Yeah, this one. This kind of example where we have a bubble that is bouncing on the screen. But we're gonna do it this time. We did it already with classes, as we can see here. We did this in many ways in the past, with different paradigms, with functions, with closures, with all sorts of things. Please refer to the previous lessons. Last time we did it with classes. Now we want to do it with classes that extend other classes. And the reason behind this is because why bounce only a small circle? Maybe we should bounce other things, right? So we should have perhaps a bouncing object, kind of an abstract class like we did with the dog and the cat. And then we'll have the bubble that actually extends this bouncing object class, and then perhaps do other things that extend also from this bouncing object. All right, so that's what we're gonna do right now. This is coming next in a second here. So let's start by defining this abstract class. We're saying bouncing object. And by convention, we said that we start with uppercase letter each time we start a class, and just, you know, to be much easier to see that this is a class. Let's have a constructor. And the logic is basically just a short recap over on this program. Is basically this kind of bouncing object will have an x and y property that it contains the current position. We also have a dx and dy properties that will be either -1 or 1 to specify the direction in where it's going. And then within the update kind of mechanism, we're gonna add the dx to the dy, eventually multiply with some sort of a speed in order to make it run a little bit faster. All right, and if you don't remember the logic how this bouncing ball happens, just refer to the previous lessons. Probably have 4 implementation or more. So okay, so let's start defining these properties that we just mentioned. Let's have a speed as a property, not have it as a constant. Then this bouncing object, again, in your mind you can visualize it like a bubble, but it's not a bubble at this moment in any way. Let's say it's somewhere random on the screen at anywhere on the horizontal, and this one is a random value on vertical, anywhere on the vertical. And then we'll have also dx, which is a random number between or not between, actually either -1 or 1. And we'll have also dy that is the same, right? And now another other 2 methods will have a display that is actually displaying something, and we'll have an update, right? Like this. All right, and let's implement now the function loop. And you know what? Perhaps it's better than just to write the code all together, and let's take it baby steps here. So let's have it first like a variable. Let object new bouncing object, and inside the loop, first of all, we'll clear the screen, and what we want to do is to call object.update and object.display. And this is the kind of a pattern that we used recently or used in animations. We are splitting the animation in these 2 methods, display and update. Display is responsible of drawing the object, and update is responsible of updating the state, like changing x and y as the object is moving, and then display is responsible for updating, right? So let's write the update method here. notice we are instantiating this thing called bouncing object, which at the end we're gonna make it kind of some sort of an abstract thing, but for now let's just say it's not an abstract thing, just to get a little bit easier to write it. All right, so we have a constructor. Okay, I forgot some parentheses here. All right, if this wouldn't be an abstract thing, let's say the bouncing object is the actual bubble, all we have to do is say here circle, for instance, the way we display it at this.x, this.y, and then a certain radius will be removed here, to be removed. But let's just put it here just to see it if this logic is working, and then update, no matter what object we're gonna bounce, either a bubble or other objects, the update will be the same. Basically they'll go in that direction until hit the edge of the screen, then we'll change the direction. So basically it makes sense to have the update method inside this super class or upper class, right? So this.x plus equal this.speed multiplied by this.dx, and the same for y, right? And then of course, if we'll just run it right now, the bubble will go to the one of the edges of the screen. So we're gonna check if we are going outside. Basically, x becomes less than 0 or x becomes greater than 800. And in this particular case, dx changes direction. Basically, we're multiplying with -1. And the same we are doing for y here. So I will just put here y greater than 600, because that's the maximum resolution on vertical, and then dy changes the direction. All right, so let's run it. Congratulations to us, we just implemented the previous program, but it's nothing special. It's exactly the same program as last time, but now it's time to actually move from this one. This we said it's a bouncing object, it's not a bouncing bubble. So this one is in a way abstract. It doesn't have any display behavior, or we can put it here like this, but it's empty, right? So if we run it, nothing we'll be able to see on the screen. And in order to see something on the screen, we have to define some more specialized classes. So let's have a class bubble this time that extends the bouncing object like this, right? And all we have to do is in this class is just to define that display method, right? Because all the logic for bouncing is already in the parent class, but display doesn't exist there. So that's pretty simple task. We'll say display, and we are displaying a circle. We are using the circle to draw a circle at this dot x, this dot y, and a radius of 5. And let's look again at this class. Just by itself, without its parent, this code would produce an error. Obviously, x is not in here, y is not in here. But of course, since we are extending from this one, they come from the parent. So this child class has access to those. So that's everything that we have to do. But of course, we are not bouncing a generic object, we are bouncing a bubble. So let's instantiate a bubble, and the rest will remain the same. We'll call update and display. Update again is coming from the parent. Display is actually the one that is overwritten. That's the terminology. The bubble is overriding the generic display that it's in the parent, right? So each time we are doing extension, the way engine is looking is, for instance, we are calling display, right? So if display exists here, we're gonna use this one. If doesn't exist here, we're gonna use it from the one in the parent. That's what's happened with the update. Display, it's exactly on the bubble, but update, since it's not on the bubble, it goes one level up and we'll call the one from the parent. All right, so if we run this one, we still have the bubble, but this time it's a bubble with classes and inheritance. First step accomplished. Let's see to what what other things can we bounce on the screen. As you can see, it's pretty easy. If we say here bounce a rectangle, all we have to do is to just say display. And again, this kind of inheritance, it's also very good. Imagine again, we are taking that thing. Imagine that we have a friend that is very, very good at programming, and we ask him, you know what, write for us a bouncing class. And our friend will write this one and give it to us in a library. We don't see the code. We don't know exactly how that bouncing happens. All we have to do is, our friend is telling us, if you want to bounce things on the screen, just extend my class that is named like this and write your display logic. And see how small task we have to do? Just this. And this is actually what's happening with the frameworks. There are frameworks out there and libraries that come with built-in libraries and built-in classes and behaviors. And if we want to use those, of course, if there are functions, we can call them and so forth. With classes, sometimes all we have to do is to extend or inherit one of those classes and basically add extra functionality. All right, so here just a quick recap about the loop function here. The loop function is specific to this environment, but it's actually it's also known as game loop or animation loop. It's a special function that gets called for us automatically. So nowhere inside the program here we are not calling loop. The browser is actually calling loop for us. All modern browsers have this capability. Loop is an abstraction here, but all modern browsers have this capability to kind of call or to be able to implement animations by calling a functions in a certain inside the event loop there. So in simpler words, this loop function gets called for us automatically by the browser about 60 times per second, right? And we had a lesson about loop, refer to that one. It's called about animations. But the principle here, we are clearing the screen each time and we are drawing the frame for each after each clearing. And it's a pretty common technique in game development and other kind of programs. All right, so let's continue this lesson about classes and see what else we can bounce on the screen. And as I said, we can bounce a rectangle, but that will be pretty simple. Perhaps bouncing a rectangle, it's just replace here circle with rectangle and that's it. Let's bounce one of these tiles, one of these characters. I mean, I said tiles because I'm thinking of a tile, but we can bounce this guy here. All right, so let me just copy it for now, just to have it handy. Yep, let me comment it out for now because it's not working like this. So let's have a class, not bubble, but what this is called, tile. I intended to put a tile, maybe. Okay, since this guy is called game, let's call it game. Okay, game extends bouncing object. All right, and now the idea is to use basically this sprite and bouncing on the screen. Sprites, if you remember, they are displayed automatically in the moment we just invoke this command. The sprite is displayed. So all we have to do is basically to change the X and Y position of this particular sprite. So let's have first of all a constructor here like this, and inside the constructor here, first thing, let's remember we have to call super. To call the super constructor, do those initializations, also initialize the object, otherwise things won't work. And let's store inside the private variable inside here, perhaps call it sprite, this guy here, right? So I just temporarily call it from outside just to see what it does. Right now, if we are calling, we don't see it until, of course, we're gonna instantiate the class here. All right, so we are skipping a reference to that particular sprite here in this sprite variable. And now what we can do, actually we can do it in two ways. So we're gonna see both. One way is basically to just have a display method here. Obviously we'll not display a circle, and inside the display method we can say this.sprite.x is basically this.x. We just move the sprite at the this.x position, and this.sprite.y is this.y. let's remember that this.x and this.y, they don't remain static. They are always constantly getting updated by our update function in here. So therefore, you know, with the bouncing circle, we just drew a circle at those coordinates. With the bouncing sprite, we are setting the sprite coordinates to this one. So obviously we should have a bouncing sprite if we didn't introduce an error. So let's check for that. So instead of instantiating the bubble, let's instantiate a game object here, and it's working. So see, again, supposing our friends writes bouncing object is pretty simple class. Nobody will write this for us and give it to us. But supposing we have a very complex behavior with some really complex movement, if we have that one created by somebody, all we have to do is just, you know, extend it and write a little bit of code just to match our scenario. All right, so we said that we can see two ways in which we can bounce this game. First of all, one way we override the display method, right? Similar to how we did it with bubble here. And of course, we are overwriting the one coming from the bouncing object, from the base class, which the base class, and yes, these classes sometimes are called the superclass, the base class, the parent class. People refer them to these terminologies, all right? So this one didn't have a display, and we are actually providing a display, right? But for this particular case, in case of the game, I'm thinking, okay, why actually override display? I'm trying to be a little bit more precise. Why override display, since this one is not displaying anything? This one is just updating some variables. So can we do it just by overriding update? Right? Let's see. Let's see. So what if we basically, we don't have these guys here. Actually, we override update. And again, I'm saying we are overriding. Update is not a new method. Also, our bouncing object has an update. So we are overriding that one. Okay, so what if we basically override that one? Our loop obviously calls update. The same is calling display, it's calling both. So it basically can, that hints us that we can place these two lines of code in any of this one, because at the end of the day, it's calling them both, right? So if we want to place them in update to be a little bit more correct from the point of view that is not displaying anything but updating, if we'll just put them like this, will not work. And the reason, again, once we overwrite a method, this one takes precedence, right? So when we are calling from here update, we'll just call this method update, and that's it. Things stop here. But this one is not doing any movement, is not checking collisions with the edges of the screen, is not incrementing X. Well, if we still want to overwrite update, and perhaps we want also to run the behavior of the upper class update, and the way we can do that, we can say here super.update, right? Just like this. So we plan to basically run all this update, and when it finishes, like we want to add 2 extra lines here at the end, basically these 2 lines. And if we run it, our tile or our game is bouncing again on the screen. And the reason I kind of, we could have obviously do it in the display, but I just wanted to also do it in update, just to show you that if you intend to override a method, but somehow you want to just add a little bit of extra behavior to that method, but you still want to continue to run the initial behavior, you can do that by saying super dot, and then you call the method. Similar to how constructors are calling the super constructor all the time, but here you don't say super.constructor, right? Just to, you don't say like that. From a constructor, if you want to call its base class constructor, you just say super here. And actually this one is kind of mandatory in JavaScript if you want to access this, so always call this one. But this one, no, it's up to you. It's totally up to you. For instance, in case of the display, even if the display existed here, because it's the base class has just a dummy display, doesn't contain anything useful, when the bubble extended the base class with the display, we don't care to call that one. We could have called it here, but is not doing any good to us because it's empty. So we'll call something empty, so it's not neat. Some people, you know, they are very careful and always try to call the base class method, and only in exceptional situation overwrite it entirely. So yeah, this will figure out in time basically. But let me save this code. Save it. Let it run. And meanwhile, I'm gonna copy it and put it here on the chat. So this is our second program for the day. Oh, actually, let me put a nicer name to this one. So this is bouncing object. Save it. All right. So this is the program. Copy program. And I'm putting on the chat bouncing object. All right, the program is there on the chat. And I still think we have time for one more exercise. So let's do one more exercise to better understand this kind of class inheritance and extension. And, you know, classes and inheriting from classes, it's a very powerful technique when it's used in the GUI interfaces, in Windows, in Mac, in all these operating systems. You see all the place widgets like buttons, text boxes, and so on and so forth. So let me grab the notebook here really quick, and basically let's discuss about a new program. As I mentioned, we have all these things, like we have text boxes, right? We have buttons like OK. We have nice label. We have labels, right? We have link labels. Click me. This is called a link label. Those ones that you click with the mouse, right, to take you to a certain address. You have combo boxes. All sorts of widgets, right? This one opens a list. Daytime pickers, and so on and so forth. So graphical operating systems basically implement these widgets, and not only operating systems, but libraries. There are libraries of widgets, and one of the easiest way to implement this kind of widgets is using classes, and not only classes, but hierarchies of classes. So the way we can do that is basically we can have here some abstract class, let's say control. All these guys are sometimes called controls or widgets, and basically from this abstract class we can inherit all sorts of controls, such as perhaps we can inherit a button, right? Or we can inherit a text box. Or we can inherit, let's take also some examples, a label. And maybe from the label we can inherit a link label, right? Because these two guys kind of look the same, but this one has extra behavior that allows to be clicked, right? So maybe this one is inherited from here. So the hierarchy actually can get pretty complex and deep. So link label can be combo box and so on, but actually one another control that it's sometimes inherited from this one, it's a window. A window, it's also some sort of a control. The difference is that window will have a controls property. I'm representing like a controls array, and this one, let me draw it with a different color, is basically has a composition kind of relationship with the control. So inside the controls we can have other controls, right? So you have a window, you know, a window. It's a typical window that will have here, you know, the regular close, maximize, minimize buttons, some text here, my window. The text is displayed here. But the reason the window has a collection of controls is because inside the windows actually will leave these controls. We'll have a button, we'll have a text box, and things like that one, this nature. So for instance, this particular window has two controls, this one and this ones. So this one are two controls that are inside the window. So that's why the windows keep a collection of controls. All right. So obviously we cannot take the task to rewrite window in one coding session or the last 15 minutes of a coding session. That would be kind of interesting if we can accomplish that. But to be realistic, we'll not be able to do that. But at least we're gonna attempt to define a few classes here to illustrate better the concept of classes and inheritance. All right, so let's start with this class that we mentioned, that we want to create some sort of an abstract class control, that is defined like that. And the control, if you imagine what are the common properties of all these widgets that we described. Some of the most common ones and obvious are the position, right? The X and Y position, right? So a control will obviously need to have an X and Y position. Buttons, text boxes, they need to sit at some coordinates, right? So let's say the control, actually let's implement a, method, set position, that will set the position in X and Y. And this is an abstract class, will not move anything, we'll just store this variable since property is X. And this dot y is y. Again, this dot x is an inner property in the object that will be created, and this x will refer to this x here that comes as parameter here, right? Well, in the same way, we can have set size perhaps that take a width and height, and we can store this one as well. What can we have? Yeah, we can have also text. Right? Because even a window can have a text we can display there on the caption there, so we can store it for now. And that's it. Okay, it's a pretty good class. So this one is mini GUI, mini UI. This is an abstract class. You see, there's no instruction here to display anything. So even if we try to instantiate it, nothing will happen there pretty much. So right now it's time to define a few more specialized classes that inherit from this one. So let's start with that button, since a button is pretty simple also to draw it. It's just a simple rectangle. So we're gonna say class, let's have it like this, button, class button, right? And of course, we don't have to care about position, about size, about all these things. What we can care about, display. It can have a method display. Actually, you know, just for exactly like we did before, we can have a display here that will not do anything, right? But in case of the button, obviously we want to display a button, right? And perhaps we should fill it with some color. Maybe light blue, I don't know what, or white smoke. What colors are buttons? I guess they come in every color. And we're gonna use the rect instruction for now to draw at this dot x, at this dot y, at this dot a, w, that's the width, and this is the height. And eventually we can also place the text, I guess, inside, but just leave it like that, just a rectangle for now. Obviously we need to place also the text inside. Oh, but this button is not yet ready. Extends control. We need to extend the control, right? How can we instantiate a button like this one? We can say let btn new button, and now here btn set position 100 pixels, btn set size, I think we call it, maybe it's 100 height and 200 is the height, and then btn display. And if we run it, a rectangle. So much code just to display a rectangle on the screen. We could have just put a rect, but okay. But things get built easy by you know, step by step. All right. Yeah, I was checking the chat here a little bit. So, all right, so we have a button that is displayed. Also, notice that to invoke set position, set size. Also, constructor can have parameters we saw last time. So if we want to, maybe when we instantiate a button, to say, okay, already a button at these coordinates, and width 100 and height 200. So basically, these guys, we can do that, but we'll have to define a constructor here. Constructor that takes x, y, width, height, and then what the constructor will do inside, we're gonna do all these 4 lines, right? And we can also leave the methods in place. You know, maybe we can invoke the constructor like this one, but we change our mind. So right now, this one are not necessary. If we run it, we still have there. But as I said, maybe we change our mind. So maybe, you know, or let's just size. Maybe we want the bigger button, like totally big button. See, this one will basically set those variables and will work. But for now, it's fine just to have it in the constructor here. All right, so this is a simple example. We have a button that extends the control. We can define a label. We can define a text box. Even the button is not completed. We have to display the text inside. We can do that if we want, right? We can use the text instruction, and we display this.text, which is basically this property, and we can display it at this dot. Actually, the text is a little bit tricky. We have to display it in the center of the bottom. We have that text mode. Let's put here text align, I think. Center. I don't recall it. We have to check the reference if not. But if we set the mode in the center, that should be basically center of the button should be this one, and this one, this plus y plus this plus h over 2, something like this. But we obviously need to set the bottom. Let's extend the constructor also to take a text here, perhaps an OK. So perhaps this one should be the first property. Text here, and we can say this.text equal text. And we didn't have to extend the constructor to take text because we already created a method. So we could have said here btn set text like this. Okay. So, well, is the same. And we have OK in the center actually, but it's not displayed properly. We have to, you know, we can beautify it, make really nice buttons if we want, like fill or no, I think we're saying no fill here, and then stroke, perhaps we want to display it with black. And this one, when we do direct, we have to have stroke black. Yeah, I think, yeah. And we have a button with OK inside. All right, so, and this is the display for the button, right? Now we can have input boxes, link labels, but we don't build Windows in a day. Yeah, let me also share the link of the project here. So if you want to basically reload it on your side, I'm gonna save it. So this one is mini UI. Again, is not complete, and I might save it meanwhile and may produce an error on your side if it's an error on my side. So, but instead of creating the under controls, let's also create the window. So also we said that a window we can extend from control, right? Let's do window because it's a little bit more special because it has that property inside where we need to have a property inside for the window to keep a collection of controls, right? So we'll have a constructor first of all. Oops, one problem. I don't have to put a constructor in the control here. All this text, well, they are particular mostly to button, so maybe buttons should have these ones, not yeah, so maybe I should move this one into the button, although all of those will have those properties. All right, so let's see, window is not doing anything for now. Let's leave it empty. Let me check if the code is still working. Yep, we need to call super before. All right, and the super constructor, it's an built-in one because we didn't define it here. We can. Anyway, I didn't want to have a constructor with so many parameters in the base class there. So we are extending this one here, right? So let's have a constructor, and of course we're gonna call super because that's what JavaScript wants before we access this. And let's have the constructor of the window build a collection to say these controls equal empty array. So basically, immediately once we instantiate a window, it builds this empty array inside. And the reason for this is because we want to have a method add that add a control. So in the moment we'll invoke window.add this button, we need to have a place to place it, right? So yeah, so basically this controls dot push. We named the method add, but the array has the push method to push it, and we're gonna push it, and the control is the ctrl, the one that we are basically receiving here. All right, so we have this one. We can have also method display, right? Because we need to render the window somehow, and we can. It is basically a big rectangle, nothing spectacular here. We're gonna fill it with a color. What color window? It doesn't matter. Light blue, I guess. Blue windows, and we can have a rectangle similar to how we had for the bottom. For the button, exactly. Yeah, we can have a stroke around the window if we want, and we have a rectangle. And you may be tempted to say that's all, but it's not all. A window, usually when it's rendered, or when we want to display a window, we don't want to display just the window. We want to display also all the child controls, the controls inside, right? So what we're gonna do here, we're gonna iterate to the control for each control of these dot controls, and we're gonna call control.display. We want also to display the inner childs, right? Because we don't want to display each control independently. Once we put the controls in a window and we say now window display, we want the window to be displayed. And in order to test this one, let's extend our program here. So we have our button. It's very good here. Let's have a window, new window, and we didn't put any constructor here to take arguments, but okay, we don't have to extend that one because we have the other one set. We have the coming from the base class. We have the set position, set size, set text, so we can use those ones. It's fine. So we can set window, set position 100 100, some position on the screen, window, set size maybe 300 pixel by 200, a smallish window, a small window. It's fine right now. And we can also have dot text if we want, or set text, and we can display it in the title of the window if we want. We have to render it, we didn't display it anyway, but let's say we don't have text for now, but has instead, it's very important, we're gonna call the add method, and what we are adding inside, we are adding the button, right? And we're gonna remove this line. Why we are removing? Because in the moment we call window display, it's the job of the display to actually display all the controls inside, right? So see, here we are just creating the window. We are setting the parameters, the various variables, we are putting controls inside, and if we have more controls, perhaps we have a link label, a links box, we can have multiple adds, and at the end we're gonna call display, and boom, this window should be displayed here. Let's run it. We'll have probably a small problem. Oops, illegal constructor. I didn't expect this one, I expected something else. But let's see, what's the problem here? Which constructor is illegal, first of all? Illegal constructor, yeah, the window one. the other one was working until now, right? So why it's illegal? Let's check it. Window, not Windows. Window. Oh, all right. But this is the second problem that I was hinting about. All right. So the button, normally in the GUI programming, when the inner child controls, they get position relative to the parent, right? So if we are taking here the notebook, just to show you really quickly what I'm saying, this is our canvas, right? And we are placing a window here. And perhaps this is 100, 100, right? And now we want to place a button here. What should be the coordinates of this button here? Usually they are relative to the window, not relative to the canvas. So perhaps if the distance here is 10 pixels and this one is 10, we should have a button as 10 and 10, right? Because why relative to the window and not to the canvas? This window can move it, right? Eventually with the mouse you drag it and the buttons will still remain relative to that particular position and not to the canvas. So right now our controls, they don't know this kind of things. They are basically they're basically displayed at absolute coordinates. So let's think what we can do. Let's look here in the code. Let's go to the button here when we are displaying the button here. Yeah. Here, obviously, we cannot display a this.x coordinate. So we have to display, switching back to this one. So in reality, although we're gonna define it like this, we're gonna say btn, or we say window dot add of a btn, and the btn was btn dot set position of stand 10. When we are actually displaying with a rectangle, we have to display it at 100, which is this distance, plus this distance, plus 10. And the same there. So basically, inside the code, we are saying 10, 10, but actually in reality, when we are displaying at 110, 110. So we have to add the two coordinates together, because otherwise, if we just display it at 10, 10, we'll basically not be displaying the right position, right? So how can we do that? Let's switch back here in the code, and a button basically, we are here, right? So we need to find some way. We need to find the actual X where we display the button and the actual Y, and then that X will go here and that Y will go here. For now we are saying this dot X and this dot Y, right? But it's not correct, right? As we see here. And let's also correct the button here. It's we said that not 100, 100. Right now it matches the window that is displayed there. But we say we want a button at 10 and 10, which should be basically in the top left corner, but the window is at 100 and 100. All right. So right now, if we run it, this is basically not the button will be here, although it belongs to the window. It should be here inside, right? So it's not obviously this X and this Y. Okay, let's get back into the upper class here, and let's say we have a method here, get real xy, like this, right? So the idea with this method is basically each control, if we'll ask it, it will be able to tell where should be drawn on the screen, right? So the control will look at the parent and then will add its own X to the parent X, right? So But how can we know for a control which is the parent? We have to extend also in other place. Here, in the moment we add here, in the moment we add a control in the code, in the collection, we are not only pushing it in the collection, let's also set a property on the control, the parent property, to say it as being this. I think this, because the window is the is basically this. Yeah. So if we are adding a button, we'll say button parent as being this window, right? And then so both will know of each other. Window will know of its children because they are added in inside this collection, and each child will know of its parent because it's via the parent property. All right. So if we have this one set up, in the moment get real x and get real y is very simple. We can basically, yeah, let's have a. So basically it's something like this, right? It's this dot x plus parent, this dot parent plus x. Something like this. We'd have to add this together. But let's see. Some controls may not have a parent. Like Windows, they don't have a parent, right? So we only controls that go inside the window will have a parent, right? So let's say let's have a variable dx is 0 and perhaps, and maybe just on this, just returning for x. So dx is 0, and now we say if this parent, so if it has a parent, dx is this dot parent dot x, right? So it has that, we read that property, otherwise will remain 0, and we have to return here, return this dot x plus dx, just like this. Looks okay to me. Let's have it also a similar copy and have it for y. We could have put it in the same function as intended before, but it's fine also to have it separated. All right, and now in here when we go to the button, and when the button will want to display itself, yeah, here, instead of displaying itself at this dot x, we'll just ask for get real x, and we'll ask for get real y. Button doesn't contain this one, they come from the parent, but it's good to put it in the parent because all the other controls that we want to have there, like the text boxes, the labels, all these controls will need to translate themselves to the real coordinates. So let's see it. Get real x is not defined. All right. Yep. All right, and we have it. But we have to do the same also with the text. So the text also we are not displaying at this dot x. We are displaying at x. This is x, and instead of this dot y is this y. So these ones. All right, and we have the OK button. So if we look right now at the code, we have, as a person, when we are building the UI, supposing the above is a library, again, we are taking this concept all the time, this is a library provided by somebody else. Now, the button, as a user, we create buttons at these relative coordinates and we add them inside. And since this button doesn't have any other, you know, it can even, we can place it here inside. You can say like that. So we can get rid of this line if we want, right? So we can have an OK button. Maybe let's add two controls just to make sure that it adds properly. It has an OK and cancel button. This one will be at 200. Yeah, and 10, doesn't matter too much. It goes outside, 150. Like that, see? So now we have a window that has basically inside two controls. And we see the composition between window and child control. They have via that controls collection. We see also the powerful of inheritance to inherit from this. And if we are really passionate about this kind of GUIs, you know, we can extend this one and implement all the other controls, make the windows fancy, because here it will create a lot of difference. Instead of a simple rectangle, if you take the time to create nice shadows under the buttons, under the windows, all via graphical APIs, like a darker shade of gray on one side, things like that. Everything will look much nicer, right? But we are approaching the end of the lesson, and we are not implementing here a full window. I'm saving this one. However, I want to show you this program. Just give me 1 second here. Let me see first of all something else. Yeah, so this is the hierarchy of controls basically that you can extend. Again, you can create more controls here, and in reality they get very, very, very deep. It's not only on this this level. It's we have windows, and also another kind of thing here. If you want to really to build this one, is we can have a container control similar to window. Actually, that's how it's many libraries they have. It's a container control. I should have put it here above. Container control. And container control has collections of these controls, and a window is just a specialized container control. But the idea is that inside the window you may have, for instance, a panel or a group box here with other controls, and that's a very powerful kind of control to implement, and it's very simple to implement it, as you see here basically, right? So yeah, so if you want to implement this one, and if you create something nice, send me a comment, and let's see what you did. Meanwhile, I'm put here on the screen a version that I completed some time ago. It's a full version. Again, even this one, it's by far not complete, but I want to give you a demo, and we're gonna look inside it. So it's exactly like what we built today, but it's a little bit more more complete. To say again, is not complete. That word, it's so it has a class with constructor similar to how we did it today. It's a lot more code here. If you look at background, for color, enable, visible, all sorts of properties that enable us to toggle these buttons. It has also interaction with the mouse, something that we didn't add today. And then basically all sorts of all sorts of other events. As you can see, I'm still scrolling. This is the button that extend that control. Has the events that basically check if the mouse is clicked or no. The text box that I mentioned. I think there are a few other. The container control, which is basically keeps a collection of controls inside, similar to how we implemented the window, but instead of putting the controls inside the window, actually we, in this particular implementation, we put the controls inside the container control. Again, methods under this one, a panel, which is a specialized container control, a label, which is also a control, things like that, a checkbox, and then a few others inside here. And we are half the library here. But anyway, let's run it and see what you can accomplish if you want. So these are the windows that I was mentioning. This one also are movable. Even you can maximize it, double click. You can minimize it, just here on the button. If you minimize it, just like this. It has this slider control. This one opens another one that runs in parallel with this one. Windows are overlapping. If you click on the one in the background, oh, this one you can draw. Totally forgot about that one. You can bring a window on top. It doesn't remove the content of the window beneath. As you can see, once I'm taking out, the content is still there. Yeah, there are a few others other small windows here. Windows are also resizable, like I'm resizing this window. These eyes are following my mouse. You know, it's just a demonstration. Here some radio buttons, checkbox, buttons, pop-ups, things that you'd expect in a UI. Of course, this is nothing that is of practical. Oh, even some mini games implemented inside. this kind of game we started to build once. Anyway, this is all with the power of classes, inheritance, and a little bit of a graphic API. So I'm gonna share also with you this particular program if you want to extend it. This is a visual sort. This is the bubble sort actually that we did it together, but it's represented in a visual way here. And okay, as I said, I'm gonna share this one with you. And I hope you like it and extend it. So Wing GUI. All right. But of course, you know, start from scratch. And again, even this one is by far not completed. The amount of work that you can put in building a UI, especially on a canvas kind of structure, it's very, very high. Of course, when you're doing development on modern operating systems, you don't have to reinvent the controls from scratch. Windows and Mac, they just solved these problems ages ago. And then inside the browsers, again, you don't have to implement the controls on the canvas because the browser, the DOM model offers other abilities to kind of render information. But it's still a practical or not practical though educational exercise to kind of try some of this one like a learning exercise. All right, so I hope that you like it. I hope that you like today's lesson, and with this being said, I want to thank you for watching and wish you happy coding, and see you next time.